these vehicles. No petrol or gas is required. Definitely, a battery will be running the system, and no emission. Definitely, the emission problems are not there. And depletion of the ozone layer, the whole formation in the ozone layer, and the heat up of this one. Okay, greenhouse effect. So many other problems. All these will be reduced, and the running cost will be very less. It will be cost effective, and very lesser maintenance as compared to the internal combustion engines, and payback period. Within a lesser amount of time, your vehicle will be giving you the payback, and no noise totally. It will be noiseless. And definitely, as we found some of the advantages, parallelly there will be some disadvantages also. Parallelly, there will be some disadvantages. We'll try to see them. High initial cost, and it may exceed more than the conventional vehicles, because a charging station is required. A very good number of the batteries are required. Very systematic arrangement of the controller circuit. Okay, transmission systems, motors, and all these. What happens? The initial investment or cost will be increasing. And today the cost is comparatively high, because once it has come in the mass production, what happens? The cost will become less. And a short driving range annexity, you can see that I cannot go for 600-700 kilometers as how I go with the petrol, diesel, and the gas engines. It will be having its own limited the range of the movement, the distance, how much the battery can able to deliver the power. Okay, the once it delivered, again it has to be recharged. Correct? No. So to have more range of, or to cover the longer distance, we need to have many batteries stored in the vehicle. So definitely it's not possible. The vehicle which will have to carry the batteries, the battery weight itself become more, and the efficiency of the engine will come down. So that nominally the weight on the whole chassis should be lesser as possible, so that it will become light in weight and we can use it, and effectively the efficiency will be increased. So shorter driving range. So now today's vehicle ranging up to 100 kilometers, they say only up to 60 to 70 kilometers. Within the city range, we can able to ride these electric vehicles. Okay, and recharging takes much longer time. You can see that the mobile itself is taking more than half an hour. Recharging the vehicle, this on lithium batteries and all, it will be taking its own time. It should be faster in. Okay, the electric vehicles charging station should have the faster charging rate. Okay, that is should be technically improved. And the family pack takes, what happens? The battery, it will be taking its own this one, the space. So whatever the family they are going to sit inside, for them it will be insufficient. Okay, 3 to 4 members if they have to go, the battery themselves they will be occupying more space if you are going to use it for the longer distance. So optimally we have to use the batteries. So batteries will be definitely covering the more space. Okay, and where you have to keep all these batteries, you can see that they cannot work in the very hot condition. They cannot work in the very cold conditions. They cannot left to the this one, the rainy this one, the droplets and all of the water should not come in contact with these batteries. There should not be electric circuit, the short circuiting and all this. So to avoid this, there should be some definite space or place wherein these batteries should be located. Okay, this is one. And what is the next? Come to the concept of hybridization. And today you can find so many hybrid vehicles. So very simple. Which I know XL6 is a vehicle. Okay, it is a vehicle, and which is a hybrid vehicle. If you are with the signal, if you are going to stop it, what happens? The ignition will stop automatically. The consumption of petrol will be zero. And simply in place of that, the electric the component will start work the engine, because load on the engine will be no load on the engine totally while it is standing. Okay, and this is multi source of power. The hybrid vehicle is one which will be receiving the electric energy as well as the energy from the internal combustion engines also. Okay. If you get into this, what happens? The size of the motor and internal combustion engine will be lesser as compared to the conventional electric vehicles, because some part of it will be taken out by the internal combustion engines to run. Correct, no? So definitely the number of batteries required will be very lesser in case of hybrid vehicles. Okay, this is one thing we have to remember. And the hybrid vehicles, as I told you, you can see them. The hybrid vehicles are those will be having the facility of the batteries along with the internal combustion engines. These batteries may be connected in series or parallel with the engines. You can see them. The engine output which is going to be waste, that will be recovered to charge the batteries in these hybrid vehicles. Okay. Most of the common hybrid vehicles have the internal combustion engines and more the one or more electric machines for the vehicle propulsion. The meaning is that, so based on the torque required, one or more. Okay, if it is simple your two-wheeler, simple batteries and more than enough to convert. Okay. Now all the new generation vehicles which are coming in the market today are hybrid vehicles, most of them. Okay. So the classification of these vehicles I have given here. I think it is not required to go in depth. And how we can classify these? We can classify them based on the path of energy flow, mechanical power transmission path, MPTP, electric power transmission path, EPTP, and combination of MPTP and EPTP. So that means to say that mechanical power transmission path, it is a simple your internal combustion engine. Electrical power transmission path, it is your the electric vehicle, and the combination of MPTP and EPTP, it is the hybrid vehicle. And how the architecture of these vehicles, it will be in the series or maybe it is a parallel, series and parallel. So if you just, I'll be showing you how these series and parallel they will be working. Okay, it's not for the examination part of you, to avoid the confusions I have not taken into. Okay, and these are some of the classifications. Classifications are not required. Electric power transmission path. Electric power transmission path. You can see them. The energy stored in the battery, which will be delivered to the electric motor or electric machine and drive system, and this electric drive system will be coupled to the rear shaft. Okay, that is called as a propeller shaft. The propeller shaft will be coupled to the motor, and so that the rear wheel will be running. And it has been shown in the reverse direction also. You can see that the output mechanical energy can be directly used to stabilize the energy of the batteries. In the other way, we can say the batteries can be recharged to certain extent by some mechanical component movement while it is running. It is about the electric power transmission path. Electric power transmission path, the energy stored in the battery that will be taken to run the electric motor. The electric motor output will be mechanical output. This mechanical output, that is a shaft, which will be coupled to the rail wheel by means of a propeller shaft. The propeller shaft and the motor shaft will be coupled by using the universal joint. Universal joint is one. The joint can transfer the mechanical output at any directions. They need not to be exactly parallel or in line. It's not required. They can be any direction, angle, and so that they can able to transfer the power. This is how the mechanism works. I don't want you to understand more depth about as per the examination point is concerned. If you want to understand more, you can get into it. Is not a big problem. Okay, and combination of MPTP and EPTP. Just now I told. Just if you want, there will be alternate ways. I want to run my vehicle by using the electric charge only, I can go to that mode. And if I want to run the engine by using only the internal combustion engine, that mode is also possible. I want to utilize both the sources, where economically I can able to reduce the fuel consumption. That is also possible by having the combination of the mechanical, okay, and electrical power transmission path. Okay, and how this will be working, you can see that the internal combustion engine output will be taken to recharge the battery, and this battery charge will be stored in the energy store, and this stored energy will be used to run the motor. This motor will be coupled to the rear wheel by means of a propeller shaft, and one path it is, and other path is, your engine, how it works. The internal combustion engine, that is the combustion part, and the transmission part is, as per now how we are going to find it out. The transmission part, it will be having the gearbox, and that will be a coupling shaft, and it will be a propeller shaft, that will be universal coupling, and this will be coupled to the rear wheel by means of a differential gearbox. Okay, this is how it will be working. It is the hybrid electrical and the mechanical powertrain. It is okay. The series and all, I don't want you to get into this. If you want, you can see them. The series hybrid electric vehicle, the engine will be there, that will be running the generator, and that will send this one to the battery will be restored. The battery will be coupled to the motor by means of a converter will be there. The converter will convert this to electric output, mechanical output. This will be connected to the rear wheel. This you can see that DIFM. It is called differential gearbox through a transmission system. Here there will be universal coupling. Okay, and how this is working, you can see them. And the advantage, disadvantage, I am not talking about this. How this parallel will be working? Parallel in the sense, the power developed by the battery source and the power developed by the engine source will be different. Those will be used at the transmission system, and again everything will be quite similar as that. Okay, this is how. And whether it is a parallel connection or the series connection, some few of the important the advantages and disadvantages, you have to study them in common. The advantages are those: the fuel consumption will be lesser, the specific fuel consumption, and that means to say in another way, we can say the mileage of the vehicle will be increased, and the pollution will be decreased as compared to the purely internal combustion engines. And another one, the engine size will be decreased because some amount of power will be given by the electric portion also. Definitely the emission rate will be decreased, and noise also will be decreased. Okay, all these are some of the advantages. The disadvantages are those: this will become a newer technology. This will become a newer technology. It will be challenging for the engineers that to develop a very systematic and efficient method by which they can able to get the output. Still, some research works are going on. With this, we have started using the vehicles. Still more few more years are required to get a proper shape of electric vehicle, which will be giving you the maximum and efficient output. And another important thing here we have not at all discussed. Here, some lithium batteries. Lithium is one which is a very important source for the development of the batteries. That scarcity is there. Okay, the only around if you compare it with the total world, we have only the 3% of the lithium source. So that has become other source the problem when whole total population of the citizen, if they are started to use the electric vehicle, the production of the lithium batteries will become very big under the problem. So how to overcome this? That is also another challenge. It will be coming under the disadvantages. Okay, disadvantages it will be coming under. And the series and parallel I have shown. both series and parallel. And here I've shown how the drive system will be working. This is just for your interest. Only I wanted you to have a look of it. Okay. All the additional things which I have given, you can go through them. And this is one R&D work we have started working on. You can see this. We have taken the photo on the 30th December 2021. Okay, this is one the electric vehicle charger. We have started developing this. Mostly within this next week, this particular engine will be coming to our SVC, so that here what we can do, in free of cost we can generate the electricity. In free of cost we can generate the electricity, so that we can use this source for the villages or where in remote areas wherein